You're welcome back to my YouTube channel, Mathematics with Edu Ada. Thank you. Kindly subscribe. Just check by the time you log in to YouTube, you check, search for mathematics. Mathematics with Edu. Don't forget this, it's an hyphen. Edu Ada. So once you check out this on YouTube, you see me, of course, see my face. Then you subscribe. Please kindly subscribe. You subscribe, you like, also make your comments. Yes, make your comments. Make your comments. You can comment. Thank you very much. On today's topic, we've started the series on differential calculus. On this video, I'll be treating application of differential calculus. Application of differential calculus. And under this, we'll be treating gradient, minimum, maximum, inflection, or what we call critical points. And we have the rate of change. So I'll take them one by one. Good. Let's start with the first. If we have something like this, like you have a graph, you have this, of course, you have this, you have this, you have this, and you have, let me say, a positive graph, such that you have, after plotting blah blah blah, you have your curve along this place, along this. So you have your slope. This is a line and a Cartesian plane. This is a Cartesian plane. So you have something like this, and you have to calculate the slope, of course. Let me indicate this, let me leave this. So you can get any point at this region. Of course, you can get this place. Let me say this is your x1. Let me call this your x2. Then I can call this y1. And I can call this y2. You get? So you can easily say your slope, which is always changing y, to changing x, that can be equal to what? Y2 minus your y1, the bigger one, on the vertical plane. So you have upon x2 minus x1. And this is the same thing as the y, the x. Don't forget. So this is what I'm going to be doing when under application of differential calculus. When we have questions that involve gradients, how do we solve them? So this is what we are trying to bring about. So let's quickly treat some questions quickly before we get out of time. Good, questions. So we have one. See examples. We have one. Example says, find the point on the Euclidean plane where the curve y is equal to 2x squared minus 2x plus 3 as a gradient. Don't forget, gradient is the same thing as slope. So how do we attempt this question on the board? Now, the first thing you consider, I said when I was explaining, the gradient of a curve or of a function is something like the slope of that function. And that implies that after you have written out the function, you just find the first derivative. the y dx, or you differentiate the dependent variable with respect to the independent variable, depending on whatever you are given. Do you get? So here now we go. We are given y. Of course, this could have been given as f of x is equal to 2x squared minus 2x plus 3. Do you get? Then you find the f prime of x. This is equal to the what? The y dx. Do you get? So now, since we are given in terms of y, we can say our dy dx is equal to what? Of course, when you are differentiating, I've done that in first principle. Yes, product rule. So go and check my videos on other methods of differentiation. You will see this. I'll explain differentiation, of course. So 2 times this, you have 4. You have 4x. So minus 2. This differentiation of a constant will give you 0. So you have the y dx to be equal to this. But now they have told us, normally if we are to look for the gradient, the value of x at the time of that slope, if you have to look for the value of x here, we would have equated our what? Our slope, which is this, to 0. Then we get the value of values of x. But here we have been told in the question, find the point xy on the Euclidean plane where the curve y equal to this has 2 as a slope. It has 2 as a slope. Mind this. So which implies that our dy dx is equals to 2. And that implies that 4x minus 2 can be equals to 2. You get? So here now what do? You can just say 4x, correct like term size is equal to 4. So dividing both sides by 4, automatically our x is equals to 1. So here, our x is 1. We are not done. We are looking for the coordinates. The point, the gradient of this curve that produces at the point at which we have this gradient to be 2. That's the one we need. So we have gotten x over 1. Good. So what do we do next? We go and substitute this in the original equation or function of that curve. So here we have this. So y, let x to be equals to 1. Okay, in let me call this star. In star. So which means you put y, since y is equals to this, all of this, you put 2 open bracket 1 all squared minus 2 open 1 plus 3. And that will be equals to 2 minus 2 plus 3. That means y is equals to 3. This and this gone. So since y is equals to this, of course, the coordinates, the points, will be equal to what? Will be equal to 1, 3. So these are the coordinates. Thank you very much. We go to the next question quickly without wasting any of our time. Example 2. Example 2 states it says determine the turning point. So we are determining the turning point on the curve y equal to x squared plus 250 upon x. Yes, this is the next question. How do we go? Let's solve. Actually, our turning point is part of the applications of differential calculus. At turning point, you are also to find the dy dx, which means you are getting the slope. But because after getting the slope, at that turning point, your slope will now be equal to 0. Simple. So here we go now. We say dy dx will be equal to, okay, let me say, okay. From what I did the other time, if we have, peradventure, you have something like this, and you add something like this, and you have to calculate the slope. So this is a turning point. So you just say the slope is somewhere here. So at that turning point, you have to equate the slope to be equal to 0. So that is what we are trying to, that's the practical application of what I'm trying to say. So you have to divide the x, of course, to be equal to 2x. We can rewrite this in a simpler way, you get? So let me write this so that you will not get it mixed up. So I can say y is equals to x squared plus 250x raised to power minus 1. Do you agree? Yeah. This for minus 1, that is 250 times 1 over x. Still the same thing. So I can say now that the x will be equal to 2x plus, this is a constant. Do you get? So you can have minus 1, then you have your 250 x raised to power minus 1, that's minus 2. So I can have 2x. Instead of this become minus, then you have 250 x raised to power minus 2. You get? So here now, what do we have? We have 2x minus 250 upon x squared. I brought it back to this form. So here I can say my dy dx is equal to 0. So at turning point, let me know that at turning point, the y dx is equal to 0. So which means 2x minus 250 upon x squared, which is our dy dx, will be equal to 0. You get? So upon doing this, what can we do to get rid of this? There are different ways to go. Don't forget we are looking for x. So here, I can decide to multiply it by x squared. I don't want a denominator. So I have 2x raised to the power of 3 minus 250. This is still 0. So what do I have? 2x cubed can be equal to 250. Divide both sides by 2. So you have this x cubed is equal to 1, 2, 5. Then find the cube roots of both sides. X raised to the power 3, cube 3, 1, 2, 5, the cube of it. So this cancels out this. So you can have your x. The cube root of 1, 2, 5 is 5. Are we good to go? We've gotten the value of that, which is determine the turning point on the curve. That is what we have, that will 5. So we can also go, okay, since it's a turning point, we can do this, it's a turning point. Let's, from here, let this be a stake like I did. Since it's a turning point, it will be a coordinate. So don't let me leave that out. So y can now be equal to, instead of 5, we put this into this, that will be 25 plus 250 upon 5. 5 here 1, 5 here, you have what? This is 50. Yeah, so that will be equal to 25 plus 50. That will be 75. So at turning point, on the turning point, that will be, you have 5, x is 5, then we have 75. Solved. That is another example. Let's have another similar example. Let's have another example. Example 3. Now, treating example 3, we have the question. The question says, for what value of x is the tangent? Is the tangent to the curve y equals x squared minus 4x plus 3 parallel to the x axis. That is another question. Now, straightforward. The definition, the question being asked there says, for what value of x is the tangent to the curve y equals this parallel to the x axis? Let me say let me say this is a curve. Just something like this. Let's say this is the equation of this curve. This equation, this is a curve. So this is a curve. Yes, let's say this is a curve. So since it's a tangent, for me, x is the tangent. For what value of x is the tangent to the curve? There's a tangent to this curve. This is the equation of this curve. This is y, which is, of course, equal to f of x. So let's say this is this. Then it has a tangent. For what value of x? Since it is having a tangent, of course, this is the same thing as x. This is the x coordinate. This is the y coordinate. This guy is a tangent. And don't forget, tangent. As it is along this path, what does that mean? It said what? Of this tangent to the curve y parallel to this. This means here that it is forming a dy dx. It means here that the gradient will be equal to 0. Do you get what I'm explaining? It means here, this is another explanation for gradients. This is calculating, just like when we say at the turning point. I explained in the previous question. So here too, is another question for gradients. This is the definition for a gradient. When a gradient occurs on a curve, that implies that the tangent to that curve is parallel to the x-axis. Note that. So we saw. So here we have it that the y, the x, will be equal to 2x minus 4. And because it's a slope, so gradient, which is equal to dy dx, will be equal to 0. That means 2x minus 4 will be equal to 0. So at this, we have the 2x can be equals to what? 4. So dividing both sides by 2, so x can be equal to 2. For what value of x is the tangent? So the point at which the tangent to the curve is parallel to the x-axis is 2. You get? If you have any question, please make it known in the comment section. Please and please do subscribe. Thank you for your time on this video. I will be bringing in another question on. Okay, let's treat another question. There's another question here. Thank you for your time on this video. See you some other time. Bye for now. But please, if you want to reach me, you can reach me on this 8164869470. Thank you very much. Bye for now.